In each of the next three examples, we're given a graph and we want to write the function that matches that graph. The first step is to identify the general type of function that we have, the general shape. In example 5, we can see that this is clearly an absolute value function, which we can pick up on because we have that sharp corner where our function changes directions. From there, we have to determine what sort of transformation or reflection was applied. Normally, our absolute value function would have its intercept at 0, 0, but that's been shifted to the right by 2 units. So what we can determine is that this would be the graph of y equals the absolute value of x minus 2 to take into account that shift to the right of 2 units. In example 6, what we have is a parabola. So we've got x raised to some even power, most likely y equals x squared. If this was originally y equals x squared, then we would have had a point at the origin, a point at 1, 1, and a point at 2, 4, and then corresponding points on the other side. What's happening in this case is that each of our values, each of our function values, is being stretched up. So in this case, from a function value of 1 to 4, and a function value of 4 all the way to 16. So that means what's happening is we're applying a vertical stretch of a factor of 4. Each of our function values is being multiplied by 4. So we would have something of the form ax squared, where in this case a is equal to 4. In our last example, or in our last example for this batch of problems, we have something that again looks like a square function. So we would start off with y equals x squared as our base. We have a reflection across the x-axis because originally our x squared function would be pointed up. And then we can also see that we have a shift, which originally would have been a shift down by 2 units. And then that reflection gets applied to flip this graph around. So we'll start off by applying that shift down, which would give us y equals x squared minus 2. And then what we would want would be f of x is equal to the opposite of that function in order to give us that reflection about the x-axis. So distributing through, we would have f of x is equal to negative x squared plus 2.